G'day, how you going? Today we'll be talking about AC sine waves. One cycle of an AC sine wave goes from 0 to 2 pi as shown. Assuming we're talking about voltage or current, an alternation has two parts. It will have a positive and negative value. Now the red arrow shows whether alternation changes values. VRMS, also known as root mean squared, can be calculated in two forms. Your first form will be VRMS equals to your V initial over the square root of 2, or the integral of the square root of 1 over t from 0 to t, V squared in respect to t. Now, assuming we have an AC circuit of 30 volts, it will fluctuate both ways, hence it's alternating current. Let's just say 50 Hertz to be fancy. Alright, so your VRMS will simply be your V initial, which is 30 volts over the square root of 2. V peak, however, will be your 30 volts over the square root of 2 multiplied by square root of 2. And you'll see both square roots will cancel out and you're left with 30 volts. Notice how V peak is higher than VRMS. This is because when you multiply by square root of 2, it then becomes a larger number. Now that we know the basic parameters of an AC circuit, I want to show you what happens when we change the frequency of an AC circuit and how it's possible to use alternating current in household appliances. In one cycle, we can clearly see the distinct characteristics of an AC sine wave. With both graphs side by side, we can clearly see the effect of higher frequency to a sine wave. But if we go even higher, we can see that it almost looks like someone drew a texture straight through the middle of the higher frequency sine wave. Now this is how we can use AC current in household appliances.